Hello everyone, welcome back to another video on NumPy. So basically NumPy is one of the Python powerful library where you can do some mathematical operations, especially arrays. So if you are working on any kind of arrays, one dimensional, two dimensional, multi-dimensional array, so you need to learn some basics. So, welcome to this tutorial on NumPy. So, one of the most powerful libraries in Python for numerical computing. So, here in this video, I just wanted to cover the basics of NumPy, and also I'll go ahead and walk through the top 25 use cases with code explain examples. So I'm going to explain. I have mentioned 25 use cases with examples, code examples, and by the end of this video, you'll have a solid understanding of how to use NumPy for various numerical tasks. So let's get started. So I'm just starting this tutorial by installing NumPy. It is already installed, but I just wanted to show how to, if NumPy library is not installed in my Jupyter notebook, so you can use this code pip install NumPy so that it gets installed into the system. And let me run this NumPy. So see, as soon as I run this pip install NumPy, defaulting to user installation, because now something I'm getting this kind of so the kernel to update the packages, something like that. So let me restart the kernel once. Give me a minute. Okay, now I'm able to reconnect my kernel. So let me import NumPy as NP. So I just wanted to start with basic operations, like I'm creating a array. So I'm assigning to a array. So the syntax to create a array is np.array, and you need to pass the list. One here I'm just wanted to create a one-dimensional array, which is a list of 1, 2, 3, list of numbers. So let me print that array. Hmm. I don't know, 1 second. Okay, so I just created a simple array, one-dimensional array. So this is np.array. I'm just passing a list of numbers 1, 2, 3. Then if I run this, then I'll be able to get this array. So let me check with since I assigned this array to ARR, so I'm checking. So this is my one-dimensional array. So this is how you can create arrays by using NumPy. So I imported NumPy as NP. So you should use NP dot array. Then you should pass the list of numbers for if you wanted to create a one-dimensional array. Okay, so that is one thing. And so let's start about indexing. So I hope when we are talking about anything like numeric numbers or alpha numbers, so characters also. For example, I have a number 1, 2, 3, 4, 5, 6. So I just wanted to look at the position of the number, like indexing method. So this is how the index method, the first this always the index starts with a 0. So the first number, for example, it could be a number 1, 2, 3, 4, 5, 6, or it could be, for example, if I wanted to look at the indexed value on a like string also, the first character it is nothing but a first index, so it always starts with a 0, then followed by 1, 2, 3, 4, 5. So if I wanted to take the slice of the string, or if I wanted to take the slice of the particular number, I can take it by using this index positions. So if I wanted to get the only 0 to 2, then I can apply slicing, then 0 to 2 I can get it. So this is how the indexing will works. So this is the first element, and this is a last element. So this is how you can get basically if I'm talking about an array, then array length, the length is 6, 0, 1, 2, 3, 4, 5, and the first element in that array, it is the indexed at 0. then 1, 2, 3, 4, 5. So that is how you can extract the elements from the array or integers or from a string. So same concept for all the topics. The indexing, whenever I wanted to get something or some slice of the uh, a string or a integer or from a array. So, and let's look at the above example with a practical use case. So since I created an array with 1, 2, 3, one-dimensional array, and I wanted to get the first element of the array. So that is why I'm printing array with an indexing always with a square bracket. So I wanted to get the element with that at the 0th position, and also I want all the elements from 1 to 3. So from here to here I want. So let me run this. Uh, so at 0th position in my array, I have number one. So that is why I got a number one. Then second time when I'm printing array 1, 2, 3, 1, 2, 3. So I have, so always the last number is excluded in indexing. So it will take 1 and 2. So 1, 2. When I'm printing 1, 2, 3, the last element will be excluded. Then I'm able to see uh, 0, 1, 2, right? Then I'm getting 1 and 2 positions. So this is 0th index, this is first index, and this is third index. So I wanted 2 to 3. Sorry, this is 0th index, this is first index, then this is a second index. I want from 1 to 3. So that is why I'm getting 2 and 3. So here I'm creating a new array 2 np.array, and this time I'm giving a 4, 5, 6. So if I wanted to do some arithmetic operations like array 1 and array 2, so we can do that. So like it will add to one-dimensional arrays. Like for example, first 1 to 3, then 1 gets added to 4, 5 plus 2, 6 plus 3, 9. So this is how it will work. So when we are working on any like mathematics, we can also add two arrays together by using this array 1 and array 2. This is like simple normal when we are adding two numbers, something like that only. But but we are adding arrays here. So again, if I wanted to reshape it, so basically the arrays is like, so anything could be an array. For example, if I am working on a larger data set which has 20 columns and 10,000 rows, so that is a big array, nothing but a big matrices. So in matrices, I mean the shape of that particular matrices is like number of rows by columns. So 20,000, if I have 20,000 rows, 20,000 by then 20 columns, 20. So we can do some matrix formulas to get something, some rank of that, or some, if I wanted to get add two data sets, something like that, then we can use this array functions there also. So that is like one use case when we are working on a larger data sets. So that is why it is very important to learn this arrays, especially linear algebra. So when we used to work on like two arrays or matrices, so in maths classes, right, linear algebra, so that is where we are using here those matrices concepts, linear algebra. So I have a one-dimensional array which is 1, 2, 3, and I wanted to reshape it. So I wanted to reshape in previously I have 1 by 3 matrix, which is a one row, then three columns I have. So now I wanted to convert it as 3 by 1. I want three rows in a one column. So you can use array dot reshape, and you need to pass the shape of the matrix however you wanted to reshape the old matrix. So previously I have 1 by 3 matrix, then I wanted it in 3 by 1, so that is why it got printed. When I printed it, so I'm able to convert this 3 by 1, 3 rows, 1 column. So that is how you can do reshaping of arrays. And the another thing is like when I wanted to concatenation and splitting. So if I wanted to club two uh, arrays, so it is like, again, when we are working on a two similar data sets, I have sales data one, sales data too, so which are both are identical, and I wanted to uh, concatenate it. I wanted to add two data sets together. So that is where we can use like np dot concatenate array1 and array2. So if I print it, then I'm able to, I mean, see, my first array is 1, 2, 3. Second array is 4, 5, 6. So both are concatenated together. That is why I got a single array, which I named concatenated array. Then I got 1, 2, 3, 4, 5, where array 1 and array 2 got concatenated together. So this is how you can concatenate two arrays together. And if I wanted to apply some statistical operations, for example, I wanted mean value, mean nothing but an average value of that particular array. So you can apply np.mean and pass that particular array. My array is 1, 2, 3, and I wanted average of that array. So np.mean and pass that array. So here the mean 1 plus 2 plus 3, which is 6 by 3. 6 by 3 is 2. So that is where it is getting the average is 2. So that is how you can apply some statistical operations or concatenation of two arrays. So you can do all these things by using this NumPy. So, and another thing, if I wanted to create an array from the list, same example, this time I'm using a bigger list. Previously I has a 1, 2, 3, and now my new array is 1, 2, 3, 4, 5. So this is how you can np the same thing like how we created in the first step. And now I wanted to create arrays with a specific data type. So this is obviously numeric integers I'm using. So the data type is int data type. Now I wanted to create with a specific data type. So that is also we can do np dot array, my array 1, 2, 3. Then I'm giving data type is equal to np dot float 32. So you need to specify which data type you wanted. So here you need np dot array. I'm creating this array 1, 2, 3, and I wanted this array to be in float. So d type you need to specify np dot float. So when I run this, so now the elements are in uh, like decimals, 1.00 something like that, 2.3 dot. So it is obviously in a float data type. So this is how you can create NumPy arrays with different data sets. But you need to specify what kind of data set you wanted. And creating arrays filled with zeros, ones, and a constant value. So this is how you can do. So if I run this syntax np dot zeros, and I wanted 3 by 3 matrix. So you must specify or pass the shape of the matrix. So here I wanted all the zeros with the 3 by 3 matrix. So this is where if I print it 0, 0, 0, 0, 0, 0, this is the first. So let me run this in a separate cell. So all zeros we can get by passing the shape. And also, so if I want ones, I don't need zeros. So that is where np dot ones, and you should specify the shape of the matrix. Here this time I wanted 2 by 4. So 2 by 4, 2 rows, all four columns. And also if I wanted to fill with a specific constant value, np dot full, I want all the elements should be filled with 7 in a 2 by 3 matrix. First you need to pass the shape, then followed by that particular element. So this is how you can achieve whenever you wanted to get all the zeros, all the ones, or you wanted to create an array with a constant element. So this is how you can create it. Okay. Now, if I wanted to create arrays using arrange and linspace method. So this is like random numbers, or I wanted to arrange it. So that is also we can do it. So this is how np dot arrange 0 to 10, and the space I wanted is like I wanted every second element from 0 to 2. So if I wanted to arrange array from 0 to 10 numbers with a second, every second digit. For example, here 0. Then the second after 0, the second element is 2, then not 3, 4, then 6, then 8. So something like that. So this is how we can also create arrays by using arrange method. And this linspace is like I wanted to create an array from 0 to 1 with the decimals. So see here, I want a 0, 0.25, 0.5, 0.75, and 1. So every 0.25, linspace is nothing but I wanted 5 elements. So I wanted to create an array with the 5 elements from 0 to 1 range. So 0 to 1 range. So if I wanted to create 5 element is like obviously it will take 0.25 difference. So that is a 0, 0.25, 0.5 and 0.75, then 1. So this is how you can create multiple arrays by using np.arrange or np.linspace. That is one thing. And if I wanted to create identity matrices, I hope everyone knows what is identity matrix. So identity matrix nothing but matrix with the diagonal values are ones. It could be anything, but it's always a square matrix. The shape of the matrix is always 2 by 2 or 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7. It's always a square matrix. Number of rows is equal to number of columns. So that is nothing but a square matrix, and all identity matrices are square matrices. So here if I wanted to create a identity matrices, uh, why I'm passing only 3, because I wanted 3 by 3 matrix, because identity matrices are square matrices, right? So and this is the syntax np dot I. If I pass this shape only 3, then I'll get a 3 by 3 identity matrix. So all the diagnosis elements will be filled with 1 in diagonal in what in identity matrices. So that is how you can create identity matrices. And so these are like some basic arithmetic operations. So I just created two arrays, 1 2 3 4 5 6, and if I wanted to add just a plus b, just like normal numeric numbers, then a minus b, a into b, a, like you can do all mathematical operations by using this mm, NumPy. And so if I wanted to do some element wise operations, so here my a is like 1 to 3 array and my b is 4 5 6 array. So I wanted to create an array with a sign, some mathematical or element wise operations. So you can also pass that particular function sign, or it could be cosine or tan, then you can pass the array. Then we can able to create a different kind of arrays by using this element wise operations. And so this is again a one important concept, dot product of two arrays. So when we are working or when we are in a school, then we used to work on this dot products. Like I have two matrices, 2 by 3 matrices and 3 by 2. So if I wanted to do some dot product, the matrices shape should be like the number of columns is must be equal to the number of rows in a other matrix. If I'm talking about a matrices A and B, so the number of columns in A, it must be equal to number of rows in B. Then only we can do this dot product. So this is the basic example how we can perform dot product, like 1 2 3 into dot 7 9. So here 1 into 7 and 2 into 9, 3 into 11. This is the first element. Then if I do dot product of 3 by 2, then 2 by 3, then I will get as 2 by 2 matrices. So these are all the basics of linear algebra. So this is how you can do some dot product of two arrays. Okay. So why I'm getting 32 here, because my A and B are, so here 1 2 3 and 4 5 6. My first array shape is like 1 by 3. So that is the reason why I'm getting only 33. So this is how you can do dot products. And if I wanted to do some multiplication on the matrices, so this is where you can create different matrices and you can do matmul. So this is the syntax to multiply two arrays together. Np dot matmul, then pass the two arrays, then we will be able to do some multiplication on matrices. So the you need to remember the syntax, matrix multiplication, which is matmul. So that is how we can do some multiplications and transposing. I hope everyone knows what is the transposing. Transposing nothing but uh, reverse. Like if I have a array of shape 2 by 3, then it will be transposed to 3 by 2. Reversed, it got reversed. The number of columns uh, changed it to number of rows. For example, here I have 2 rows, 3 columns. So transpose of this matrices is like 3 rows, 2 columns. So the number of rows and number of columns will be exchanged or reshaped. Transposing a matrix turns rows into columns. This rows will become columns now. This is the first row, this is the second row. So I got my first row become first column, second row becomes second column. So this is what transposing means. And if I wanted to get the transpose, so I should array dot t. T nothing but transpose. So we can do a dot t, then that will transpose the original matrix. That is how you can do transposing. And if I wanted to get a Boolean indexing, like this is my array, I wanted to get the elements where this condition satisfies. If I can give some condition like array of the numbers which is greater than 2, I wanted the numbers which are greater than 2, 3, 4, 5, something like that. If I pass that condition, so we can able to get by using this array of greater than 2, then we will be able to get all the elements which are greater than 2. So that is another use case. And this is like a fancy indexing, like 0 to 3. And if I print array of indices, then it will give me the +1 numbers. 0 becomes 1, 2 becomes 3, 3 becomes 4. So that is what it will do. Fancy indexing and sorting an arrays. If I wanted to sort ascending order or descending order, so see, always if I apply np.sort and applied or passed this array, then I got ascending order 1, 2, 3, 4. So if my original array is not in a order, then if I apply np.sort, then it will be sorted. And also if I wanted to get in a descending order, you need to pass it. Like I wanted to descending is equal to true, then I'll be able to get the descending order in the descending order. And if I wanted to get the unique elements from an array, so you can apply np dot unique. Since all are unique numbers only, there are no duplicate values. If I mean, for example, if my array has 1 2 times or 2 2 times or 3 2 times, then it will be removed and I can able to get only unique values. So since my original array does not have any duplicate values, so that is the reason why I'm getting 1 2 3 4. All the elements are unique, so I'm able to print entire unique elements. So np dot unique we can apply, then you need to pass the array. And if I wanted to apply some statistical functions like mean, median, standard deviation, something like that, so we will talk about mean, median, mode, standard deviation, range, all these things in coming videos. So but for now, if I wanted to get a mean, just np.mean and array, np.median and array, np.std means standard deviation, then you can pass that array. Then we can able to get all statistical functions by using NumPy. If I wanted to get the mean value of that array, standard deviation of that array, median of that array, we can able to get all these things. So this is how you can get the statistical functions. And so if I wanted to generate a random number, so we can do that. So if I wanted to generate a random array by using random numbers, so we can achieve that np.random, then dot rand 3 by 3. So I wanted random numbers in a 3 by 3 matrices. So the syntax is np.random dot rand. I need to pass the shape of the matrices. I wanted 3 by 3 matrices with some random values. So my 3 by 3 matrices got filled with some random numbers. So this is how you can generate a array, random array with this random like syntax. And so this is if I wanted to save my created array and I wanted to load that saved array. So this is how you can do it, np.save. So if I have saved my uh, original array with my array.npy comma array. So this is the file name. So and if I wanted to load it again, np.load with the file name, then we'll be able to get it. We can able to save it, and also we can able to get the saved file also by using these syntaxes. So this is again a similar thing, reshaping arrays. So where I wanted to reshape from different shape of the matrices to a different shape, we can also we can apply the syntax array dot reshape. And flatten arrays, like if I wanted to get a flatten array, then we can apply array dot flatten. So here I'm using this reshaped one because the original array is 1 2 3 4. In this here I'm reshaped it to 2 by 2 square matrix. That is why it got 1 2 3 4. Again, I'm if I wanted to convert it to a original array, that is where you can use this flatten. So reshaped value is 2 by 2. Then I'm applying the syntax reshaped dot flatten. Then I'll be able to get back to the original array, which is 1 2 3 4. I can convert it to a different shape, and again I can get back to the original shape by using this flatten. And this is again concatenating arrays. So I can concatenate two arrays together, and this is splitting. So if I have a bigger array and I wanted to split it into 2 parts, 3 parts, 4 parts, so you need to verify the syntax is np dot array split. Then you need to pass that particular array and how many sub arrays or how many subparts you wanted. For example, if I wanted to split the original array into 2 parts, then mention 2. If I wanted 3, then 3. So this is how you can split the arrays. And this is like broadcasting, like one array and like adding normal mathematical addition. And this is vectorizing functions. For example, I created a new function and I wanted all exponential of that number. So this is how you can apply vectorized function np.vectorize. And if I pass this my custom defined function, then I'll be able to get this 149, because my x is like 1 to 3. The square is 1 square is 1, 2 square is 4, 9 square, sorry, 3 square is 9. So this is how you can also apply customized functions on like on arrays. So if I wanted to get something out of it, like by using where function or conditional operations, I wanted all the numbers which is greater than 2 uh, and array. So and indexing, I am passing negative -1. So in reverse order I wanted. So that is where if I print it -1 -1 3. So this is how you can also apply some conditions, and you can retract the required data from array. So this is like again a use case when we are working on a larger data set, which where if I have some missing values, so I can also handle those missing values by using this NumPy array, which is np dot. This is my array. I am creating a array with some missing value 1 2. See, np dot none is like a missing value. I do not have anything in the third position. Then 4. So I'm just printing np dot is an array. Then it will show if there are any null values are there. Then the Boolean function will show like true. Wherever the null values are there, the true will come. And if I wanted to handle np dot non to numerical, so I'm converting this to a numerical data type. This because I wanted to fill some like a null value with a 0. Then you can apply this np dot na into numeric, then apply array, then the null value will be replaced by 0 1 2 0 4. So this is how you can handle the missing values and uh, like numpys. So that's it for our NumPy tutorial. So these are like basic 25 use cases. I think most of the cases I have covered. So this could be like useful. These are the like basics. So if we have practiced a lot, then we can able to apply on larger data sets or larger arrays. So here we just talked about the 2 by 2, 3 by 3 normal arrays, simple arrays. It could be a one dimensional or two dimensional, but when we are working in a large data set, similar operations can be applied there. So I hope you guys found this video helpful. So if you have any questions or topics you'd like to see covered in the future videos, so please leave a comment below. So please don't forget to like, subscribe, and hit the bell icon to stay updated with our latest content. So I hope you guys are understanding whatever I'm trying to explain. So this is what I have for today. So thank you guys for watching the video. Bye.